let's get at it here. Greetings again, everybody. Trigonometry for students and surveyors. Lesson 20. We've been working this board pretty hard. All I wanted to show you now, we finished this off yesterday, or the last lesson was lesson 19. Made the corrections. The backside northwest bearing equals 283. That's the azimuth. That's where the confusion was, but we got it all straightened out. So I've been promising I was going to turn to show you how to take notes on this. So that's what we're going to do. I'm going to flip the board where I got some sample note, and the sample note kind of a little bit crude, I got to admit. Didn't come out quite the way I was hoping it would, but it'll do the job. So what we did is we sat here. These 2 points, we're pretending they were already there, 2 rebars. We sat there, got our backside azimuth, turned this angle 298, 33, 28 down to this new point 212, set a mag and washer, sat there backside of that. Then we shot this manhole rim, and that's manhole 1, existing manhole 1. Shot the rim, got a measure down, got the invert elevation. Shot this manhole 2, shot the rim, got a measure down, got the invert elevation. Calculated the slope on that, which is a 5% slope. We set a new manhole. We staked out, they want a new design manhole. It's going to be a saddle manhole that sits right over this and sits on it. It's going to tie in a new plat. It's going to be tying their section of the plat into this existing road at 0 plus 78, so 78 feet from that one. So we did all that. So we just have to go back to that lesson. So that's what we're going to do. So now I'm going to show you how you might take notes on something like that. So let me, bear with me, I'll flip the board here real quick. All right, so here's a notebook. We take these, this is Rite in the Rain. I think these are made right here in Seattle. They usually have their Rite in the Rain story on them. These are survey books. Well, they use them for anything. These are field books, but they're more or less weatherproof. You write your heading here, so I'll kind of show you that. But there's certain columns in here and rows and columns, and there's kind of a reason for them. And then over on this right side, it's a finer rectangles here. That comes in handy when you're sketching up a house or a building. That comes in really handy. There are other ones that have this same rectangular size on both sides of the paper. And if you'll notice, this one doesn't have page numbers. Some of them do. They're not all exactly the same, but you get the idea. So you have columns and rows. So I'll set that aside for now. That's a hard field book. There's soft ones, little ones, big ones. Okay. So I basically tried to copy the same amount, the same row, same columns, 1, 2, 3, 4, 5. This thicker line represents the center of the book. And then this is the other columns on the other side. So this is kind of how, by the way, there's lots of leeway in this, and you don't have to do it this way. I do want to say, but we shouldn't get away. There's a little bit of a bad trend lately. These successive generations seem to get farther and farther away from taking notes. I think that's a bit disturbing. Notes used to be absolutely critical. Everything was having to done. Well, you had to do more longhand stuff like we're doing with our calculator anyways. So you had to take down notes. We're going more and more electronic, so you don't have to take, sometimes you don't really have to take notes. But it's a good idea to take notes certainly on certain things. So it's a good thing. I just think if you're a survey manager or company owner, you should have your chainmen and your party chiefs. They should have to present very good, clean notes to you. And if you say, well, you don't have to take that, then that's fine. You can work backwards from there. But they should at least meet a minimum standard. Our motto at my last company was above the standard, and I certainly tried to live up to it and try to encourage everybody else to live up to above the standard. So so what we have here, this is the top of the page. We have our job name. This is what I like to do, is I put the job name over here. Now, like I say, you can put it over here, you can switch things around. What I would do is maybe copy something like this, take it into your office and say, how do you like it like this? How do you like it? Or they already might have a template that they want you to follow. If that's the case, that's what you want to do. So on the other side of the book, job name, and it'll be a title. Your date of the date, or the date, and then your initials. So the party chief first, slash, and then the chainman. So I'm using old terminology: chainman, rodman, survey technician. It's getting fancier names for all this stuff. Assistant, associate, whatever you want to call them. It's your helper. Your job number. Those usually have like a date, a dash, and then another number. And then you want a page number for sure. Now, a lot of other guys, they might want you to put the temperature, whether it's raining. You might want to put the temperature, the humidity. You might even want to put your gun, and whether it's a 5-second gun, a 1-second gun. You can put all that in there. I've never really bothered with that. I've never had any issues with that, because you have, what goes along with this, when you send all your data in, you have a raw file, and that has all that in there too. This is really good for the the notes are really important for the guys that are following you up, for yourself when you go back to a job, or somebody following you up, so that they know where to get started. So with our columns in the book, we have 1, 2, 3, 4, 5. We have the beginning, and then we have this gap here. So we have it laid out: station, horizontal angle, horizontal distance, slope distance, zenith angle, and rod. Rod is the height of the rod. Then over here on this side, now this is for construction. If you're doing something else, you can put a different kind of a heading in here, or no heading. This column here, so you're going to have your rod, and then you're going to have an elevation. So this is what we just call hub elevation, or just elevation. Usually it's a hub. It could be something else, like over here, rim. Hub elevation. Then you're going to have a design grade. And over here, the C/F is cut and fill. That's construction stuff. And then a store number. Whenever you get done taking a shot, you want to store it as a store number, and that usually goes in this column. So you have a column for everything. Now, why is that important? Well, one reason, if you look at somebody's notes and you see a distance, let's say, for instance, here's a distance, and they just write a distance. Maybe they might write an angle and a distance, or they just write a distance. You don't know if that's a slope distance or a horizontal distance, and you need to know that. If you put it, if you have a system, and if you have a template that you all follow, and you see that the distance is in this column, usually they'll write the zenith angle and the distance. If you're calculating, they'll usually go in pairs. So, and if you have an angle over here, like for instance, a zenith angle might be confused with a horizontal angle unless it's in the correct column. So it's very important to do that. And you could get some confusion otherwise. Now, usually when you're calcing, in the old days we had, these are robotic guns. Well, I don't know if that is, but we have robotic guns now where they turn and they follow you. You go in your calculator, you select the point you want to stake. It'll either, you can make it turn to that thing, or you can just go where you think it is, close to where it's going to be, and it'll start shooting you automatically. It'll just guide you into where that point is. Prior to the robotics, you always had to have at least 2 guys. You had to have somebody running the gun, turning the angles, and you had to have somebody out on the rod. And so what you do is you calculate a point, and the gun, or your data collector, would tell you what angle to turn and what the distance was. So you turn your angle and you say, oh yeah, so it's that way, it's 150 feet from the gun. And then they get out there, and then when they get close, you give them another shot, and so on and so forth. You get them on, and it gets actually quite fun when you got a really good partnership going, a really good system going with two experienced people. It's real fun. It's quite fun teamwork. So you have horizontal angle, horizontal distance, slope distance, zenith angle, rod. Over here you have the hub elevation. So you're going to shoot something. All right, so we're going to trav ahead. Oh, and also, all right, let's just start the first row. On the other side, we trav'd, I showed you that back side was 283 something. That's our trav point. That's a little symbol for the little gun there. Trav at 211. And then we're going to measure up a 522. So and then you have okay, when you get there, those points, we're going to assume they were over there. There's a rebarred cap on both of those. And you can also write all that stuff in too. It's a good idea. RC, hub, tack, whatever. It helps people. The more information you can give them, the better. Unless you just keep going back to the same site. It's a construction site. I get it. Everybody gets it. I get it. So you have a Travet 211, backside 210. And so you set your backside up, you shoot that distance, and then you want to reference that. You want to say field book, see field book number 2. So in other words, one team, one party, one crew might have went there, set these, went to another job, and then me and another crew go there, and we're seeing these two things. We're saying, well, where did this come from? Where do these come from? Are these just 2 GPS points? Are they 2? What's the quality on this? So you want to be able to kind of do a little research before you feel comfortable moving ahead. So it says see field book number 2, pages 6 through 8. Okay, so you get that book. You probably have seen that already before you went to the job site, and you'll have that book with you, or it should be in your file. You should have a whole complete file for this job. Then you'll look in that book and you'll say, oh yeah, this came from there, that came from there. Everything's good, everything's checked and so far. Good confidence with that. Okay, so then you got your rod has an elevation on it, and you give it a measure up, so that gives you an HI. Now you can write that in if you want. I kind of like to do that, especially as I was teaching. I'd write a lot more stuff in just so I could show my students a lot more exactly how it's going. But your rod elevation, or that rebar elevation, has an elevation. Then you measure up to the gun, and then that becomes your HI, and that's really where all the action's coming from. That's where all the measurements are coming from, the HI. That stands for height of instrument. Same with your back sight. You have an elevation on your rebar and cap, measure up 513, and then you have a height of rod. Actually, that says height of rod. That should just be a measure up of the rod. Those two together become the height of rod. You got your field book. Then you want to do a back sight check. You want to check your back sight. Set it up, you shoot it. And I told you before, you don't have to measure. You don't have to necessarily measure what you have. You don't even have to have a quarter. You just have to know what that back sight azimuth is. And this one is 283/2117. You have to know what that is. Because sometimes you can shoot, like I said, a radio tower, church steeple, building corner, as long as you've done control and have the right and accurate bearing on that from this point. All right, so anyway, but most of the time we'll shoot them. This will be our back sight calc. This is the calc distance, because you'll inverse it. You'll get that back sight bearing, back sight azimuth, and then you'll get a calc distance. Then you'll shoot it, and this will be what we call the residuals, horizontal and vertical. The horizontal, that's the error between what it's set and what you measure. And so we have 0.006, so that's tenths, hundredths, thousandths, so that's 6 10,000ths on the horizontal, 1/100th, 0.010 on the vertical. That's fine. You get all that, then you hit set. And that takes your gun and it sets it at 0. Now again, don't be confused. It still internally knows that its backside is 283/2117. But you set it at 0 so you can easily track your angles and measure your angles. You can actually set these data collectors to backside. I think it's called, we use a backside, I think it's called 360 on the Leicas. I think you can call it north. If you said north, I think it would literally, when you hit 0, when you hit set, this is the number that's going to come up, 283/2117. The problem with that is when you start calculating other angles and adding angles, you have to stop and add them to that. And you don't want to do that. Everything's going to be 0, but 0 is going to be pointing at. I think that should make sense by now. So back in the old days when we had these kind of guns, we would put down the angle, and that's all we would write down. We'd write down the angle and the distance, And then we shoot the guy in and get him in there and store it. Then once it was stored, you can write the zenith angle and the slope distance. That's another check. Especially if you're not storing. Back in the old days, they didn't even store stuff. They just wrote this down. What that was their check. Okay, so we're turning in. I got CP and TRAV, control point / TRAV. I think I gave you a little talk yesterday that they're, or maybe it was already today. They're usually one and the same, but not always. And that TRAV point is 212. That's our station. Station is basically where you're going, what you're doing. All right, so that's going to be 212. That's the angle we turned. Yeah, and that's right. That's the angle we turn. That's our horizontal distance, our slope distance, our zenith angle. We use our zenith angle and our slope distance, cosine of the zenith angle and our slope distance to calculate the vertical. We use our zenith angle and sine for our slope distance to calculate the horizontal distance, and vice versa. That's all back in the previous lessons when we were solving triangles and using sine, cosine, and back and forth and back and forth. That's why it's good to know this stuff so you know really what's going on in that data collector. Okay, so now we've turned, we have a 533 rod from our HI. So now we have an elevation. So what it did is it shot that prism that's at about a 533 rod, and we set a mag and washer, and it subtracted that 533 from the prism, and now this is the elevation at the mag and washer, 354, 94, 54. I kind of end up crowded. I got my columns a little too close, so I crowded my writing. And when I realized, by the time I realized that, I wasn't going to do it over. So I'll talk you through all this blobs. And then hardly anybody ever writes down the station, but it's a very good, or the northing and easting. So you write down the northing and easting. You got a mag and washer, and then of course you're in our store points or store numbers. Well, I stored that at 212. It's called 212. One of the reasons for that is like the next day somebody else comes and I haven't had a chance to download the job into the computer at work, and they haven't had a chance to upload it to the new guys or the new crew that's coming out here. So they go out there and they say, well, get that trap point at least set on that, and we're going to change that manhole. We're going to move it 14 feet down because of this, that, or the other. There's a conflict with the gas line. Okay, so somebody goes out. They didn't get their upload, so they sitting on that new trap point, and they don't have a coordinate, but they look in the book. Now they have the new coordinate, and then they can do the back sight, and they're off and going. Another thing we like to do on construction sites is write the coordinates on the back of the lath, the 4-foot lath. So there you go. So that's it. So we have that set. We have that new trap point set, and that's all on the other side. You saw the picture earlier, or you saw the graphic on the other side. Now you move ahead, and I always like to skip a line. Here's the thing, guys. The paper's free. The books are free. The companies will give you them. What they would like to get is clear, legible, easy to follow notes. And a lot of times we used to keep space between every row. One of the reasons is you might shoot a bunch of curves and have all your grades in there. And they might say, well, we need to, we have a design change. All those curves are going to be changed. So you have to go along with your design curve grades, and they'll change it. So they can use that spare line, that gap, and red letter the new curve grades in there. And then you go out, because you already got your hubs in the ground, and then you can go out and go to each stake and fix it. And it's easy if you have room. If everything's crowded in, there's just no room to redline stuff and to check stuff. And so, like I say, there's plenty of books. They can buy all the books they want to buy. They want to be, I think any company will be happy to buy more books if they're getting legible, clear notes that everybody can follow, the drafters can follow. Everybody so it makes sense. Because invariably, at some point, a job's going to go a little sideways, and they're going to want to trace down what happened. And if they have a good set of legible notes, it helps a lot. they're also, as I said earlier, they're legal records that could be submitted in court in case something got built wrong, and now we're going to trace back whose fault is it. It'll come back to the survey. It'll come back to the license, whoever's licensed at that company. So my message to owners of companies, survey managers, it's in your best interest to make your guys take the best notes they can, best notes that serve your purpose and are good legible notes. All right, so we traved to 212. Now we're moving up. We had a tripod there. Now we moved the gun up to 212, and we put a prism back on 211 where we just came from. We got to measure up. Now on the Leicas, and I think probably the Trimbles are the same, but not all instruments are the same. Not all backsight glasses are the same. We traveled to a prism that was 533. So now we get there, we pull the prism up, set the gun on it, take the prism and put it back there unless we have a second prism. It's going to be the same measure up. You can double check. It's a good idea to double check it, but it's going to be the same measure up for the Leica. It's very handy to have. And now we're backsighting 211. Again, same prism height as 211 was, 522. Okay, so now we're doing our backsight check. Now here I didn't write in the horizontal angle or the horizontal distance. We got our zero, horizontal distance, slope distance, or zenith angle. We have all that coming this way. You can. It never hurts to put in more information. But we do have our residuals here. We wrote those down. You got to do that. So we have 3 10,000ths, 8 10,000ths, very tight, nice, and that's what they're capable of doing. And then we have our new backside azimuth of 41, 54, 45. So there you have that. So you're set. Then you hit, when all that's done, you hit set, and then you'll look right on your gun and make sure that it sets at 0. We've had guys, well, I've done it myself. I've made every mistake there is to make many times. But what happens is sometimes you'll get going and you'll measure it, you'll write it down, you'll forget to hit set. Then you just start shooting, say a topo, a whole road. Shoot the whole road up, and you forgot to set. So you have an angle already in there, some goofy angle, whatever it was when you set the gun on there. It's just some angle. Now you start shooting, and when you're done, everything's off. If you could figure it out, it can be rotated, but sometimes you might have to shoot everything over. You've wasted your thing. So make sure that when you're all done, that's why at my old company, we used to do this. The new company people don't do it. They don't even know why, how you try to explain. I always put 0, so it's a check. It's a backside check. You're checking, you're setting. It's a systematic check. You write it down, and that makes you, just like the reason you write other things down, it makes you double check. So now you got 0, you're looking at the gun, it's zeroed out, ready to go. Oops. All right, so then on the other side, you remember we shot the rim, we had angles and stuff to the rim. So manhole 1, this is existing. If I would have had a little more room, I would have wrote existing. We turned to 204, 11, 19, horizontal angle to that. It's 91 feet away. The slope distance is that. The zenith angle is that. The rod is 510. Now, why are these all 510? They could be anything. These rods slide up and down. My rod used to go to 5, but it seemed like it got a little something was jamming in there. So everything's 510. Everything that's low, the lower the rod is, the more accurate it's going to be, if you just think about it. So 510, so when I do any tight work, it's 510. Sometimes you can't, you got to raise the rod up over a car. So I have my favorite heights, 510. When I'm topoing, I have it over my head. I'm 6'3", so I have it at 6'4". So when I'm walking away, it can still shoot behind me. I don't have to walk backwards. So, but no higher than it needs to be. And I won't even go into how things need to be calibrated and plumbed and everything. So we have all that stuff to there, to the manhole, to the rim, 510. So we ended up with a rim elevation of 327, 0465. That was all on the other side. We all worked on those calcs on that diagram. We have a measure down of 18 feet, so we have an invert of 309, 0465. So not necessarily used writing that here. That's not really typical in a construction layout, but we are we are traveling to this point, shooting those things and designing a new thing. So that would normally be done in the topo, in the topo portion of the job prior to that. But as you can see, we're doing a demonstration here. So we just did that on the we're kind of doing it on the fly. So we have all that. Then we stored that. So then we minus that. We store that as 23,000. So we took the rim elevation, subtracted 18 feet. That's our elevation, but we stored it at 23,000. Well, 23,000 is going to be that rim elevation, and that's just fine. We have that. We can work that in later. We can go in and manipulate that coordinate, or we can create a duplicate coordinate, or we could shoot the rim, and then with the 510 rod, and then we can shoot it again, and we have what's called an offset in these programs. And we could put a vertical offset of negative 18 feet, and we could store that. It would have almost exactly the same northing and easting, the XY coordinate, but you would automatically subtract 18, so you would end up with this 309.0465 at 23,001, say, although I use that down here for this number. Ignore that for now. So you could have two coordinates for the same manhole. It just depends on, that's something you could try. Maybe you want to try that, give that a try. If you're if you're in construction surveying like now, you could maybe throw some comments in there and see how you guys, let me know how you guys like to do it. But that's one way to do it. Same, so now manhole 2 is the one that was over here, 8741.32, 73 feet. Horizontal distance, 75.7510. Slope distance, 105.2919. Zenith angle, 510 rod again. Rim 340.0465. Measure down to the center of the channel was 24 feet. We have invert elevation of 316.0465. And this one I stored at 2301. Okay. So if we did do our measure down, if we did do the vertical offsets with these and store this as, say, 23,001, and this one 23, and then 23,001, and then say this one 23,002 and 23,003, we can inverse those two ones that have the vertical component already factored in, and then you would get your, not only would you get your distance, but you'd get your slope. You'd get that 0.50 slope that we have on the other side. It would just come right in. So that's how we do that. And then over here, now we're staking. So this is really, we're getting more like staking. So now we're going to stake 40 manhole, the new manhole, design manhole, 37, and I have a 12-foot offset. Now this angle is actually to the center of the rim, so this is not, I just wanted to show you how we do it in the field. So we're going to have a manhole 37 is in our station. That's telling us what we're doing, what we're going. And that's manhole, or that's a 12-foot offset. 12-foot offset, because they're going to have a pretty good dig on that. We have a cut of 18 feet. So they're going to have a pretty good cut. So we're going to go 12 feet on that one, not 10. You can go 10s and 15s, 12s and 20s. Again, throw some comments in there if you guys have, other ways to do that. So that's our horizontal angle, and that's our horizontal distance. Now again, we're not putting these in here. You can after you shoot it, but we're putting that in there so we know what the angle is, we know what the distance is, we shoot it. And the reason you don't have to necessarily put all that in the point, because you're going to store that one as well, 23,002. You can always inverse to find out what your zenith and your slope is, or you can look at your files at work. You don't really need to do that. Like I say, we used to store everything, mainly because they either didn't trust these, or the coordinates didn't come, you didn't store the coordinates, you're just doing it field book with books, calculators and books. So if you stored, so this is your calc, your slope distance and your zenith angle, you won't get that until you actually shoot it. So then you can compare these two to those two and make sure you've done it right. So your hub is 3, so now you've set a hub. A hub is, I should have brought all that stuff in. It's just a square piece of wood. It's about an inch, maybe a little bigger. No, I think it's about an inch square, maybe 1.125 square. It's whatever the width of a 2x4 is. What would that be? 1.5? Yeah, I think it's 1.5 by 1.5. Yeah, 1.5 by 1.5 hub, and they've got a point on them, and they come in various lengths for the depending on the kind of ground you're going to be pounding it into. And you should paint them orange or some color, bright color on top, and drive them in. And you can put a tack in them for depends on how accurate you have to be. That's called a hub and a tack. So anyway, so we've driven a hub in at 12-foot offset to what that coordinate's going to be. We've shot it now with the gun, with the zenith angle, all that. Now we come up with a hub elevation of 331.16. Now we've calculated the rim is going to be 333.95. That's our hub elevation. That's our design grade. Our design grade for the new rim is going to be 333.95, and that should fit that existing road. That should pull that out. That rim's going to match that road. In theory, it will. And then we have that elevation, that IE, and that we established that by taking that slope, going 78 feet, adding that vertical to the first IE. That would be this guy over here, and we come up with 312.95. And then, if you recall, we continued on that out to check to the second one to make sure that we were right. That we always do checks. And so we have a rim of 333.95. So the difference, the hub elevation, let me just put that in to show you, 331.16, and then we want 333.95 minus, so we have a fill of 279. Again, this is going to be a negative because we're going the other direction. So that's a fill, and we put an F and a plus. I usually just put a dash, but some of the guys I work with, they were putting a plus just because the contractors get a little care. Oh, is that a minus? An F and then a minus? Which way is it? So F, fill, plus fill. 279, and that'll get you to the rim. So they'll take that hub, use their spinning laser, and make sure that they'll go up 279 from that hub. That's where that rim elevation will eventually be. So on here you have the design grade of the invert elevation is 312.95, which we calced on the other side of the board here. You have 331, enter, 312.95 minus, and then we have a cut. That's how you do it. There's a cut of 18.21 to the invert. So they'll know that, and they'll go get they'll order the right size length manhole, and they'll have the knockouts in it for their pipes to go into, and then they'll lower that manhole until that invert matches that. They'll have their track hoe with their cables on it, and they'll go in there and they'll lower that to where they need it to be, and they'll already have packed gravel at the bottom of their big hole that they have, and they'll lower that in there, and they'll get that just right, and then that'll be a cut of 18.21. When they get all done, they'll backfill it and pack it. They won't put the rim on there until they get some other stuff done, especially on a new plat. The final rims can move until they get the road the way they want it. And then we'll store that one. All these go in the office now, and they can check what you've done. They can check. You have a raw file that tells them everything. You have a coordinate list that'll come in. Everything can be looked and evaluated. And then over here, we have our 12. We have the same manhole. We have a lineup now, a 20-foot lineup to that. That's so in here. Normally those hubs, they're just lineups. They don't have to be super solid. They're not going to really carry a grade, but there are exceptions. And you write lineup, 20-foot lineup to manhole 37, and then they'll pull their tape through those two hubs till they find, or till they arrive at where they need to be. And then and those will stay there while they're putting the thing, and they can continue pull back and forth until they get horizontally and vertically just the way the design of it is in the civil plans. It'll be bang. And they're pretty good at it. So that's what notes are like. And this is, you know, you kind of ran out of room and got a little crowded here, but this is sort of how it's done. I always like to put a big broad line between my setups so that it's really easy to open up and see where your setups are. One other thing I want to talk about here, we have, so a 211, these are just my old numbers from the last job I had. My range was 200 to 299. So I'm assigned those for traverse or control points. If I get over, you know, if there's a very few jobs, and for any job, each job starts new. If I start a new job, I'll start at 200. So you never get past 299. I don't think I've ever put in 99 hubs or 99 control points. If you have a job that big that has more than 99 control points, you're more than likely going to have other surveyors working on that job as well. It's probably a big construction job, and they're going to have their own point range. So then you jump up. Now the numbers between say all the different, say all of the last survey would be 900 to 999. Then you jump up to what they call the office calc numbers. So you stay away from those, let the office calc those numbers. They'll calc numbers, and then that's what they upload to you. My topo numbers were 20,000 to whatever, again, it's such a high number that I can go as far as I can go to 30,000, 20,000 to almost 30,000. It just shows them if you have these categories and with your point ranges, it's easy to see what the shots are. Oh, that's a topo shot. That's a construction shot. So this construction 23,000 plus, as-built are 27,000 plus. So it's easy to see what you're doing. So now, if I was topoing, which is mapping a road, mapping a field, mapping a farm, whatever we were mapping, wetland flags, trees, whatever we were mapping, and you have topo. When you have a setup, say we're at 211, 210, you want to put your point range. Now you don't have to, you'll have this, but you'll want to put your point range, say 20,000 to 20,486 under this setup. Then when you get to your new setup, then you'll start 20,487 to 20,000 whatever. So that you have your topo shots coincide with your setup. You don't want to have setup, and then all your daily topo shots from 20,000 to 20,800, 700, all just jammed there, because you want to be able to pull those notes apart and say, okay, we have something going on here. This shot, what setup did it come from? It just helps everybody, helps you yourself, saying you did these shots from this setup, you did this group of shots from that setup, this group of shots from that setup. Same with your as-built, same with your construction, so on and so forth. It helps you organize your notes, and helps everybody in the office sort, because things are going to go sideways somewhere, somehow. Something are going to go minor sideways. We used to have a saying that if you catch the error before the concrete has been poured or before it made a real problem on thing, then it's not an error. It's just a stumble. And that's the thing. If you're redundant, if you check and check again, and have check-ins with your control, then you're in good shape. Now I know this is kind of survey specific. It's not so much for general students, but it's interesting, and students who are not going to be surveyors, it isn't going to hurt to see how we do this and how we use trigonometry and stuff. So I think that'll do that. Well, that's the notes. I said I was going to do notes, so we got the notes. I'll show you books later, and later on, I'm going to just continue these, as I go. They'll probably space them out a little bit more, these lessons, as I get into summer and I start doing more activities outside, hiking and kayaking and canoeing and mountain biking and family and all the stuff that we like to do. So they'll be a little more sporadic, but I'll probably be getting, once I get out of the basic trigonometry, the basic stuff that we're going to do. We're going to go into curves pretty soon and all that other stuff. Then we'll start working through the LSIT test. So I could help you. We'll pick out problems and put them up here, and we'll work them out together. So that's how you would lay that other side of this board out. That's kind of how you would lay that out if you were with your field notes. And I think that's it. So really interested here. If you have comments, throw them in there, and let's get a discussion going. Also, I'm a member of, I think about 4 or 5 Facebook survey groups. I really enjoy getting on those and seeing what everybody has to say. There's surveyors all around the country. I'm even on some world survey sites now. Very interesting stuff. Very fun to engage back and forth on that and to see how other people in other parts of the country uh, tackle problems or go about. Generally speaking, they're very similar, but there's definitely, so don't hold me to this, or don't say that this is the authoritative way to do it. This is a way, but there are certain columns here that lend themselves: station, horizontal angle, horizontal distance, slope distance, zenith angle, rod. Then if you put your distances in the right column, there's not going to be any confusion what the distance is. And same with your angles. If you put your horizontal angle over here, your zenith angle in this column, anybody that has that same format, that template that's working off that, they'll know what that means. Avoids confusion. Because that's all we do. We work with numbers all day long. We work with numbers. It's easy to get confused. It's easy to juxtapose numbers. For some reason, that's a very common thing with surveyors. Is 72 becomes 27, and it's like, well, why isn't that working out? It just happens. It happens. All right. Well, thank you very much. That's going to be enough for that lesson number 20. And please like and subscribe. I appreciate it very much if you do so, and pass this around other surveyors, students, and comment. Please comment, and we'll get the conversation rolling.